one last example here, finding the inverse. In this case, you could be given a formula for your function, a table to describe your function, or a graph, and then also be asked to combine your knowledge of finding the inverse with your knowledge of finding combinations and compositions of functions and so forth. So the question at hand is the following. Let h equal 7 minus 2x. Use h, the table that's given describing f of x, and the graph that's given describing g of x to evaluate g inverse of f inverse of 3, g inverse of h of 3, h inverse of f of g inverse of 3. Okay, so that's a lot of symbols. So basically when I look at this question, I see lots of g inverse, f inverse, h inverse, and then composition. So I will make it my personal first order of business to find each inverse function. So let's find h inverse first. And actually really doesn't matter which one we find first. We just need to find all of them. Okay, so if we find h inverse, h of x is a formula, 7 minus 2x. So our first step will be to let h equal 7 minus 2x as we were given. Exchange h and x, so I'll have x equals 7 minus 2h. And then the last step would be to solve for h. And when I solve for h, that will be the function h inverse of x. Okay, so it's linear in h, so I will subtract 7 from each side and have x minus 7 equals negative 2h. You can multiply through by negative 1 and then divide by 2, or you can divide by negative 2. You take your personal pick. But regardless, when I end up with h in this formula, then I basically have the inverse function. Okay, so this tells me that h inverse is the formula negative x plus 7 all divided by 2. Okay, so I'm going to circle that. All right, now next up, I have the graph of g. You may find it easier to take the graph of g and translate that into a table. You may find it easier to read. So on the graph of g, if I have the ordered pair negative 3, 2, that means x is negative 3 and g of x is 2. Also, I'm given when x is negative 1, g of x is 1. When x equals 2, g of x is 3. And lastly, when x equals 3, g of x is 5. Okay, so I could take the graph and make a nice neat table. And then for f of x, we were given a table anyway, which if I needed to, I certainly could turn into a graph. But in this case, since we're going to be composing functions, it's probably best to leave a formula or a table. So we have 2 goes to negative 1, 3 goes to 5, f of 9 is 4, f of 4 is 2, and f of 5 is 3. Okay, so I have actually all three guys defined. H inverse is a formula. I have a table for G and a table for F. Now here's the point. If I have a table for G, then I automatically have a table for G inverse by exchanging the ordered pairs. So if G of negative 3 is 2, then G inverse of 2 is negative 3, and so forth. Likewise, my table for F leads me to a table for the inverse of f. And note that we said that f of 2 is negative 1, so f inverse of negative 1 is 2. F inverse of 5 is 3. F inverse of 4 is 9. Okay, F inverse of 2 is 4. And F inverse of 3 is 5, and that's swapping all the ordered pairs. Okay, so I'm taking a little time to do this just to show you one way you could think about it. Okay, now, in part A of your question, you're asked to find G inverse composed with F inverse of 3. Now I'll take my definition and I will think, okay, that means G inverse of F inverse of 3. Okay, if I want F inverse of 3, I'm going to go to my red table and find 3 is the input and F inverse of 3 is the output. Then if I want G inverse of 5, I'm going to go to my blue table, find 5, and G inverse of 5 is the value 3. Okay, so hopefully you see how this works. Okay, now secondly, if I want G inverse of H of 3, then that means, literally H of 3 is substituted into G inverse. And to calculate H of 3, we need to go back to our formula for H, which is 7 minus 2x, and substitute 3 into 7 minus 2x, obtaining G inverse of 7 minus 6 or 1. Therefore, we need to calculate G inverse of 1. And we can see in the table that G inverse of 1 is the value negative 1. And lastly, we need to do H inverse of F of G inverse, taking a pair at a time, working inside out. We need H inverse of F of G inverse of 3, which is H inverse of F of the value, one second here, G inverse of 3. To get G inverse of 3, we go to the table for G inverse and we see that the value 3, as we've seen earlier, is mapped to the value 2. And then we'll have to deal with H inverse of F of 2, which is H inverse of, and F of 2, again goes to the value negative 1. And finally, H inverse of negative 1 means we substitute negative 1 into the formula for H inverse. Which gives us 8 over 2 or 4.